Backend pools and health probes. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Now let's dive into configuring backend pools and health probes in Azure Front Door. These components are crucial for ensuring your application remains available and performs optimally. I'll explain each configuration option and share best practices I've learned from production deployments. Backend pools in Front Door, called origin groups in the new terminology, are collections of your application endpoints. These can be Azure services like App Service or virtual machines, or even on-premises servers accessible via public IP. The key difference from Application Gateway is that Front Door backends must be publicly accessible. There's no private VNet integration like you get with Application Gateway. When creating an origin group, the load balancing settings are critical. The sample size determines how many recent health probe results Front Door considers. With a sample size of 4, Front Door looks at the last 4 probe results. The successful samples required sets how many of those must be successful. 3 out of 4 provides good reliability without being too sensitive to transient failures. The additional latency parameter is fascinating and often misunderstood. When set to 50 milliseconds, Front Door considers any origin within 50 milliseconds of the fastest origin as equally good. This prevents constant flapping between origins with marginally different latencies. For example, if your East US origin responds in 20 milliseconds and West Europe in 65 milliseconds, only East US receives traffic. But if West Europe improves to 69 milliseconds, both origins are considered equal, within 50 milliseconds of each other, and traffic is distributed based on weights. Health probes in Front Door work differently than Application Gateway. Instead of probing from a single region, Front Door probes from multiple edge locations globally. This gives you a true picture of global availability. If your application is healthy from US locations but failing from Asia, Front Door knows this and routes accordingly. The probe configuration requires careful thought. The path should be a dedicated health endpoint, not your homepage. I recommend creating an endpoint that checks all critical dependencies: database connectivity, external API availability, cache status. Keep it lightweight though. Remember it's being called every 30 seconds from multiple global locations. The probe protocol should match your application. If your app redirects HTTP to HTTPS, use HTTPS probes to avoid false positives. The timeout should be less than the interval to prevent probe overlap. Front Door uses HEAD requests by default for efficiency, but you can switch to GET if your health endpoint requires it. Origin priorities enable sophisticated failover scenarios. Origins with priority 1 receive all traffic when healthy. Priority 2 origins only receive traffic when all priority 1 origins are down. This is perfect for active-passive setups. Weights distribute traffic among origins with the same priority. An origin with weight 50 receives half the traffic of one with weight 100. One pattern I love is using different origin groups for different types of content. Create one origin group for your API servers optimized for low latency, another for static content optimized for throughput. Front Door's routing rules can send /API/* to one group and /static/ to another, giving you fine-grained control over traffic distribution. Routing rules and path patterns. Routing rules are where Front Door really shines, giving you incredible control over how traffic flows to your backends. Let me walk you through the configuration options and show you patterns that work well in production. Creating a route with a ZAFD route connects your front-end domains to back-end origin groups. The endpoint name specifies which Front Door endpoint this route belongs to. Remember, you can have multiple endpoints per profile, each with its own routes. This is useful for separating production and staging environments. The patterns to match parameter accepts wildcards and specific paths. /* matches everything, while /API/* matches only paths starting with /API/. You can specify multiple patterns like /API/star and /v2/star to route both to the same origin group. The order doesn't matter. Front door matches the most specific pattern first. Custom domains are linked to routes via the custom domains parameter. A single route can handle multiple domains, which is perfect for handling both www.example.com and example.com with the same configuration. You can also have different routes for different domains going to different origin groups, true multi-tenant architecture. The supported protocols parameter determines which protocols the route accepts. HTTP allows only HTTP, HTTPS only HTTPS, while HTTP and HTTPS accepts both. For production, I recommend HTTPS only, with a separate route to redirect HTTP to HTTPS. This ensures all traffic is encrypted. The HTTPS redirect parameter with enabled automatically redirects HTTP requests to HTTPS. This happens at the edge, before traffic reaches your origin, reducing load on your servers. Combined with HSTS headers, this provides robust security. Now let's talk about caching, one of front door's most powerful features. The caching parameter with enabled turns on caching for this route. Unlike traditional CDNs, front door can cache dynamic content using query string parameters as part of the cache key. The query string caching behavior has three options. Ignore query string treats all URLs with different query strings as the same, useful for tracking parameters that don't affect content. Use query string creates different cache entries for each unique query string, perfect for API responses that vary by parameters. Ignore specified query strings lets you exclude specific parameters from the cache key. Compression at the edge is another performance booster. With enable compression set to enabled, front door compresses eligible content before sending it to users. This happens even if your origin doesn't support compression. The edge servers handle the CPU overhead, not your origins. Route ordering matters when patterns overlap. Front door evaluates routes in order and uses the first match. Put more specific routes first. /API/v2/star before /API/star before /star. You can update route order using the Azure portal or by recreating routes in the correct order. One advanced pattern is using routes for canary deployments. Create two origin groups, one for stable and one for canary. Use front door's rules engine, which we will cover next, to route a percentage of traffic to the canary group based on a random header or cookie. This gives you gradual rollout capabilities at the edge. URL redirect and rewrite rules. URL manipulation in front door happens through the rules engine, a powerful feature that lets you modify requests and responses at the edge. This is where front door becomes more than just a load balancer. It's a full application delivery platform. The rules engine processes requests after routing rules but before sending to origins. Each rule has conditions and actions. Conditions match on various request attributes, like URL path, headers, cookies, or client IP. Actions modify the request or response, redirecting, rewriting URLs, adding headers, or modifying cache behavior. Creating a rules engine configuration starts with a ZAFD rule create. The rule name should be descriptive. I use names like redirect apex to www or add security headers. The order parameter determines execution sequence. Lower numbers execute first, so security rules might be order 1 while feature flags are order 10. URL redirects are one of the most common use cases. The condition might check if the host equals example.com, without www, and the action redirects to www.example.com. The redirect type can be moved, 301, found, 302, temporary redirect, 307, or permanent redirect, 308. Use 301 for permanent changes like apex to www, 302 for temporary maintenance redirects. The redirect protocol lets you force HTTPS during redirects. Set it to HTTPS to ensure all redirected traffic is secure. You can preserve the original path and query string with Preserve Unmatched Path, essential for maintaining deep links during redirects. URL rewrites are more subtle. They change the URL sent to your origin without the client knowing. This is perfect for API versioning. Requests to /API/users can be rewritten to /v2/API/users before hitting your origin. The client still sees /API/users in their browser. The rewrite syntax uses capture groups. A pattern like /API/parenthesis.** captures everything after /API/. The rewrite destination /v2/API/captured zero bracket inserts the captured content. You can have multiple capture groups and reference them as captured zero bracket, captured one bracket, etc. Header manipulation is another powerful capability. You can add security headers like X-frame options, content security policy, or strict transport security at the edge. This ensures consistent security headers across all your origins without modifying application code. Custom headers for backend communication are invaluable. Add headers like X frontend host with the original host value, or X client IP with the real client IP. Your origin can use these for logging, security, or application logic. Front door automatically adds X Azure FDID so origins can verify traffic comes from your front door instance. Cache control through Rules Engine gives fine-grained control. Override cache duration for specific paths. Cache images for 30 days, but JSON responses for 5 minutes. You can even bypass cache entirely for authenticated requests by checking for authorization headers. One pattern I recommend is progressive enhancement. Start with basic routing rules, then add rules engine configurations for advanced scenarios. This keeps initial setup simple while providing room to grow. Always test rules thoroughly. A misconfigured rewrite can break your entire application. Web Application WAF configuration. Configuring Web Application WAF on front door is crucial for protecting your applications from common web vulnerabilities. Let me walk you through setting up WAF policies and tuning them for your specific needs. Front door's WAF operates at the edge, blocking malicious requests before they ever reach your origin servers. This is a huge advantage over regional WAFs. Attacks are stopped at the edge, saving bandwidth and compute resources. The WAF inspects every request against a set of rules, looking for patterns that indicate attacks. Creating a WAF policy starts with a AZ-network front door WAF policy create. The name follows specific constraints. Only alphanumeric characters, no spaces or special characters. The mode parameter is critical. Detection only logs potential attacks while prevention actively blocks them. Always start in detection mode to understand your traffic patterns before switching to prevention. The SKU parameter can be standard Azure Front Door or Premium Azure Front Door. Premium includes additional managed rule sets and bot protection. For most applications, Standard provides excellent protection. Premium is worth it for high-value targets or when you need advanced bot management. Managed rule sets are pre-configured rules maintained by Microsoft. The default rule set provides protection against OWASP Top 10 vulnerabilities. Version 2.1 is current as of this recording. The action at the rule set level is the default action, typically block. Individual rules can override this. The real work in WAF configuration is tuning rules to prevent false positives. Every application is different. What is normal for one might be an attack pattern for another. The AZ-network front door WAF policy managed rule override create command lets you adjust individual rules. Common rules that need tuning include SQL injection detection for applications with complex queries, and cross-site scripting rules for sites with user-generated content. The rule ID identifies specific rules. You will find these in WAF logs when investigating false positives. Set action to log to disable blocking while still monitoring, or allow to completely bypass the rule. Custom rules give you complete control. Create rules that match your specific needs. Block requests from certain countries, require specific headers, or rate limit by IP. The AZ Network Front Door WAF Policy Rule Create command creates these rules. Priority determines order. Lower numbers execute first. Rate limiting is essential for preventing abuse. Create custom rules that limit requests per IP address. The condition matches on socket ADDR, client IP, and the action is blocked with a rate limit threshold. A limit of 100 requests per minute per IP stops most automated attacks while allowing legitimate users. Geo-filtering is another powerful feature. Create rules that allow or block traffic from specific countries. This is useful for compliance requirements or reducing attack surface. The condition uses remote ADDR with a geo-match operator. Be careful with VPN users. They might appear to come from unexpected countries. WAF logs are invaluable for tuning. Every blocked request is logged with details about which rule triggered, the client IP, and the full request details. Use these logs to identify false positives and adjust rules accordingly. Azure Monitor workbooks provide excellent visualizations for WAF data. One pattern I recommend is progressive hardening. Start with managed rules in detection mode. Analyze logs for a week, tune false positives, switch to prevention mode, then gradually add custom rules. This ensures you do not accidentally block legitimate traffic while building strong security. Caching and performance optimization. Let's explore Front Door's caching capabilities and performance optimization techniques. Understanding these features can dramatically improve your application's speed and reduce origin server load. Front Door's caching happens at each edge POP independently. When a user in Tokyo requests content, it's cached at the Tokyo POP. A user in London triggers a separate cache fill at the London POP. This distributed caching model ensures users always get content from the nearest location, but it means popular content might be cached hundreds of times globally. Cache keys in Front Door are sophisticated. By default, the cache key includes the protocol, HTTP/HTTPS, hostname, path, and query string. This means http://example.com/page and https://example.com/page are different cache entries. Understanding cache keys is crucial for optimization. The AZ-AFD route update command configures caching behavior. When caching is enabled, Front Door caches responses based on standard HTTP caching headers. If your origin sends cache control public, max age equals 3600, content is cached for 1 hour. Without explicit headers, Front Door uses heuristic caching based on content type. Query string handling dramatically affects cache efficiency. With query string caching behavior set to ignore query string, URLs with different query parameters share the same cache entry. This is perfect for tracking parameters like UTM_source that don't affect content. Use query string creates separate cache entries for each unique query string, essential for APIs where parameters change the response. The Ignore Specified Query Strings option provides fine-grained control. You can specify parameters to ignore while including others in the cache key. For example, ignore UTM_star parameters but include category and sort. This balances cache efficiency with content accuracy. Compression at the edge is a major performance win. With Enable Compression set to Enabled, Front Door compresses text-based content, HTML, CSS, JavaScript, JSON, using gzip or Brotli. This happens even if your origin doesn't compress. The CPU cost is absorbed by Microsoft's edge infrastructure, not your servers. Cache purging is essential for content updates. The AZ-AFD endpoint purge command clears cached content. You can purge everything with /* or specific paths like /images/logo.png. Purges propagate globally but take time, usually 2 to 3 minutes to reach all POPs. Plan your deployment processes accordingly. Performance optimization goes beyond caching. Front doors split TCP terminates client connections at the edge and maintains persistent connections to origins. This means a user in Sydney connecting to an origin in US East doesn't suffer the full route trip latency for TCP handshake. The Sydney to edge connection is fast, and edge to origin uses an existing connection. Dynamic Site Acceleration, DSA, helps even non-cacheable content. Techniques like route optimization over Microsoft's backbone, TCP optimizations, and connection pooling speed up API calls and dynamic pages. Enable DSA by ensuring your routes include dynamic paths, not just static content. Monitoring cache performance is crucial. Front Door provides metrics like cache hit ratio, bandwidth savings, and origin shield effectiveness. A low cache hit ratio might indicate too short cache durations, burying query strings, or missing cache headers. Aim for 80% plus cache hit ratio for static content. One optimization pattern I love is the cache everything approach with smart purging. Set long cache durations, days or weeks, for all content, then use targeted purges when content updates. This maximizes cache hits while maintaining content freshness. Combine with versioned URLs for assets, style.v123.css, to avoid purging altogether. Thank you for your attendance. Please consider subscribing to the channel.